The heights of students in a certain school are normally distributed with a mean 170 centimetres and standard deviation 5 centimetres. Find the probability that a randomly selected student is under 176 centimetres, over 168 centimetres, and between 167 centimetres and 174 centimetres. So if we let x be the random variable, the height of a student in a certain school, then the height of the student x will be normally distributed with a mean of 170 and a standard deviation of 5. But the second parameter of a normal distribution is the variance, but it's better to write it as 5 squared, i.e. the variance is 25. So these are the two parameters. The mean, and sigma stands for the standard deviation, and sigma squared stands for the variance. Variance is the standard deviation squared. So we want the probability that x is less than 176. Now it's a good idea to draw a diagram. So here the mean is 170, the standard deviation is 5. Where is 176? It's somewhere around here. So you put a line and then you want less than, so you shade to the left of that line. Okay, and therefore, if you're going to use the standard normal curve, now before the days of graphic calculators, you didn't really, you had to use the standard normal curve because you were given a set of tables for the z being normally distributed with a mean of 0 and 1. So you had to standardize each probability. To standardize, you take the probability, you take away the mean and divide by the standard deviation. So that would give you, if you did that, 176 minus 170 divided by 5. Now, that would give you that probability z is less than 1.2, and then you'd go to your tables and look that up. Now, you don't necessarily have to do that now, but you do need to be aware of how to standardize a normal distribution for later, more difficult problems. So we'll look at both methods using this video, but you really only expect to be able to do this and come up with the answer with your calculator. So on the graph, that would be 0 for the standard normal curve, that would be 1.2, and the standard deviation would be 1. Now, you've probably got a calculator. I'm going to use GeoGebra, the probability calculator in GeoGebra, to do this. And I'll show you how that works, but you can do the same on your graphics calculators. Most Casio TIs will do this as well. So I want my GeoGebra. So this is when I get GeoGebra 5 I'm using. And then I want to view the probability calculator, which is that one there. So I will use that one there and open it. Opens up in the normal distribution. Now, it might be that it's lower down like that to begin with. Okay, and then it's already set for the normal standard normal curve, because mu is 0 and the standard deviation is 1. So I want the probability of z being less between 1.2. Right, so in order to do that, now you need to put in a lower value on your calculator, but on this you could get away without doing that, but we'll just look at it so it's like the calculator. So you need to put in a value here, so just put in a very low number for minus infinity, because this curve goes off here. So something like a minus 1,000 for the lower value, and the upper value I'm going to put to be 1.2. And that gives me a probability of 0.8849. So make sure on the calculator as well that you're using the normal CDF or CD, depending on the type of calculator you got, 0.8849, and we would round that off to 3 significant figures of 0.885. Now, if we were using a mean of 170 and 5, I could put 176 in. So let's just do that. So let's change the mean to 170 and this to 5. Okay, and then in here I need to put in something like a minus 1,000. And in here I need to put 176, you'll see that it gives the same answer, 0.8849. And this is probably what you would do on your calculator, but knowing how to standardize is actually quite important. So in the next example, we are going to do the probability of x greater than 168. Okay, so drawing a graph. Okay, so 170 and sigma is 5. It's always nice to draw a graph because you get a sort of visual representation of what's happening. So we want more than 168, so it's going to be that area there. If we standardize it, z would have to be equal to 168 minus the mean, which is 170, divided by 5, which means that z would have to be bigger than minus 0.4. This would be 0 and this would be 1. So going to GeoGebra, so I'm just going to change these now back to 0 and 1. So that's the mean and the standard deviation. So this is now minus 0.4, and in here now I need to put in a big number, like something like 1,000 or even 10,000, and that will give me an answer of 0.6654. Okay, and then rounded off, that would give me 0.655. So just going back to that, this would be your lower value on your calculator. This would be your upper value using a mean of 0 and 1. If you used a mean of 170 and 5, and in here now you put 168, and again for the upper value you put in a high number, 1,000. Okay, you can see you're going to get the same answer, 0.6654. Okay, so now between 167 and 174. So if you're going to standardize it, you need to do 167 minus the mean 170 divided by 5, and then 100, and then z being less than 174 minus 170 divided by 5. And so that's going to give the probability that z is between minus 0.6 and 0.8. And again, if we draw that on a graph, it's always a good idea to do a very quick sketch of what's happening because it gives you a much better understanding. 170 and 5, that was 167, which is that one. This one, 174 is over here. We want the bit in between, so we shade that bit there. Okay, so that is minus 0.6, 0 and 0.8. So going to GeoGebra, so changing these back to mean of 0 and standard deviation of 1, and we want this to be minus 0.6 and 0.8. So this would be your lower value on your calculator, this would be the upper value. These values normally come underneath on the calculator. So if we press enter, that will give me a answer of 0.5139. So I've got 0.158 on the calculator, but rounded off, that will give me 0.514. And then if I did it using the actual values, so this will now be 67. This would be 174, and these we need to change to 170 and back to 5. And this is probably what you would do in the first instance. Sorry, 167. Sorry, so this is 170 mean sigma 5, 100 and the probability of x being between 167 and 174, we get the same answer, 0.514. So this has been a video to show you how to use the normal curve and the standard normal curve to find probabilities. I apologise, it's been a long video, but I have used the probability calculator in GeoGebra for doing this, but you maybe would use your calculator. I hope you've understood, and I thank you very much for watching.